Bismillahirrahmanirrahim. I am Muhammad Ehsan Chatta, Assistant Professor, Government Degree College, Chichawatne. Dear student of the BSc Physical Chemistry, third year as well as fourth year, let us learn about quantum mechanics article Schrodinger wave equation. In order to provide and meaning or to the probability approach, Schrodinger derived an equation known after his name as Schrodinger wave equation. Calculation of the probability of the finding the electron at various points in an atom was main problem before Schrodinger. His equation is the key point of wave mechanics, is based upon the idea of the electron behave as standing waves around the nucleus. This equation is depicted here. Let us to learn about these equations. Student, dear student, you know that psi pronounced as SIGH, psi, it represents the amplitude of the wave, and its square, psi square, represent the electron density at various points. Psi is equal to A sine and theta. We place 2 pi x over lambda. We differentiate this equation with respect to x-axis. We taken the partial differential equation of this as delta psi over dx is equal to a multiplied by 2 pi lambda cos 2 pi x over lambda. Similarly, if we take the square on both sides of the equation become d square psi dx square will be equal to a into 4 pi square divided by lambda square sine 2x into x over y. As we know that a sine 2 pi x over lambda will equal to wave function psi, so put the value of the psi in above equation. We get d square psi dx square is equal to 4 pi square psi over lambda square. Kinetic energy of the particles on the mass m and velocity v is given as half mv square. If we taken this kinetic energy equations, we take the square on both sides of the equation, then this equation rearrange themselves. Student, according to the Broglie equation, we know that lambda is equal to h over mv. and taking square it will become lambda square is equal to h square over m square v square. M square v square will be equal to h square over lambda square. Substitute the value of m square and v square. We get the kinetic energy equation 1 over 2 into h square divided by m lambda square. Similarly, from the equation third, we taking the squares. If we want to determine the lambda square, the equation rearrange it's 4 pi square psi divided by d square psi divided by dx square. Substituting the values of the lambda square, we get kinetic energy will be equal to 1 over 2m into h square over 4 pi square psi into d square psi over dx square. These equations, on rearranging and solving, we get the minus h square 8 pi square mv psi multiplied by d square psi over dx square. We know that total energy is equal to sum of the kinetic energy and potential energy. Kinetic energy will be equal to total energy and minus जो है potential energy. Hence we get from the above equation minus kinetic energy is equal to minus h square 8 pi square m psi multiplied by d square psi over dx square. Similarly, again we rearrange this equation by placing the values of the total energy and potential energy. D square psi divided by dx square is equal to minus 8 pi square m over h square parenthesis start total energy E minus potential energy parenthesis closed multiply by whole with psi. Let us to the next equations. Dear student, this equation rearrange again as d square psi over dx square plus 8 pi square m over I square parenthesis start E minus potential energy parenthesis closed multiply by psi is equal to 0. The Schrodinger equation in one dimension, it is generated from the particle whose motion is described in space with respect to 3 axes x, y and z. Thus with 3 axes d square psi over dx square plus d square psi dy square plus d square psi dz square plus 8 pi square m over h square parenthesis start total energy E minus potential energy parenthesis close multiply by V is equal to 0. This is the simple form of the Schrodinger wave equation, and here psi is pronounced as wave function and it represents the amplitude of the wave, and its square represent the electron density, the finding of the electron at any point. डेल्स 3 डायमेंशनल जो है वो चेंज represented with del square and known as Laplacian operator. The Schrodinger wave equation is second degree differential equation. Sum of these are imaginary, are not valid if the total energy and corresponding wave function can be calculated. Here we place on both sides the Hamiltonian operator will be equal to the E psi. This is the wave equation, or known as Schrodinger wave equation in one dimension. Thank you, student. Allah Hafiz.